you can read as many books as you want. Unless you put them in practice, you're not going to be learning. So something that I recommend people is create a habit. I'm a huge fan of having these small habits that will over time will accumulate and make me grow into certain areas.
All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser. I'm a data scientist at iWoka, and I will be your host. So today, our guest is Santiago Valdarrama. Santiago studied computer science in Cuba, and he worked there as a software developer. But at 28 years old, he actually moved to the US, and a few years later, he joins Levatas as a software engineer. In 2015, he decides to go back to university to do a master in computer science at Georgia Institute of Technology. And this is actually where he starts to get into AI. So he transitions to the world of machine learning within Levatas, and he is actually now the head of computer vision there. But on top of this, he also has his own YouTube channel, he posts on Twitter, and he created Bnomial, a website which posts one machine learning question every day. So if you enjoy the episodes, subscribe to my YouTube channel or leave a 5-star review. All right, so let's start now. Hi, Santiago. Are you ready for an episode of AI Stories?
I am. Let's do it.
Great, great. Glad to have you here. So, first question, just wanted to know a bit more. Why did you transition from Cuba to the US? Why did you move?
Yeah, so it's not a secret that Cuba is not going through their best economic conditions. So that's been happening for a long time. So when I graduated college, I basically wanted a better life for me and my family, and that's what I decided to come here. So yeah, like you said, I came when I was 28. Uh, I knew somebody here that person offered me a job. Dear friend of mine. I'm super grateful for him here, and then yeah, everything went from there. I was able to bring my family here, and yeah, that's basically the reason. It's just economical. It was much better for me and my family. Yeah.
Okay. Since then you decided to stay. I guess you still like it.
Yeah, I kind of like it. Yeah, for sure. I'm, I'm, I really like it. I stayed here in Florida. When I came first, I went to Tampa, Florida, but then I moved here to West Palm Beach. It's closer to Miami. It's about 1 hour north of Miami. And the weather is beautiful. It's very similar to the weather in Cuba. So it's hot, humid. I know people don't like humidity, but I'm used to it. And yeah, I really enjoy it. It's a beautiful, beautiful place to live for sure.
I'm sure you're getting better weather than in London, probably.
Yeah, a little bit. Yeah, for sure.
All right, so I mentioned that you started as a software engineer, right? And then
Yeah.
you moved to machine learning and AI. So can you talk a bit about this transition? Like, how did you get into the world of the AI, data science, machine
Yeah.
learning?
Yeah, it was interesting because back in college, I was in college in the early 2000. 1999, I started college until 2004. Back then, I remember having AI professors, but the field was very different to what it is today. I mean, we're talking early 2000, where most of the stuff that we use today didn't even exist. Like,
Mm-hmm.
yeah, we were talking about neural networks and we were talking about a bunch of techniques that became popular later, but back then, none of that it was very hard. Only a few people found practical use out of those things. So I guess not surprisingly, I wasn't very interested in those classes. So even though I took the classes, I never paid attention. Just I wanted to build things, right? And I was building software back then. But then, 2015, I did it for a long time. So I spent years and years as a software engineer building software. And even in 2015, like you mentioned, I went back to college because I wanted to get a master's in computer science. And I had no idea about machine learning. I didn't go to college for machine learning. That was not my plan.
Mhm.
While I was in my master's, I took a class, a machine learning class, just because I needed the credits, not because I wanted to take the machine
Mhm.
learning class. So I just needed 3 more credits. And I went to the machine learning class, and something happened, something that I think it was magical for me at the time. I was exposed to a set of solutions that I could immediately apply to some of the problems that I was working on that I didn't have access before. Like, I saw how to solve problems that were completely out of my reach before taking that class. So I got into this cycle where every day I was going through a
Mhm.
class and learning something new that was helping me in my day job. And I think that got addictive really quick. So I decided, even though I was about to finish my master, I was about to graduate, I decided to stay for a little bit longer, added a bunch more classes to my, to my list. I added computer vision, I added reinforcement learning, so a bunch of machine learning related subjects. And then I graduated with a major in machine learning. So that's what I wanted to do then, and that's it. That's since that day. Uh, I think it's been great. I've been in love with the field. I think it's it gives me a different dimension to what I do every day. I usually say, even though like people criticize me because I say this, but just
Mhm.
it's an oversimplification. But I say that in software, we usually find problems that there is a line, and when you cross that line, you're done. Like, it's not hard to find problems that are either not solved or solved, and when you solve them, that's it. It's done. In machine learning, it's way harder to find this type of problems. It's usually an incremental improvement situation. It's usually like, when are you done with a model? Like, if you look at these big models that are just mind-blowing, they make a ton of mistakes. Clearly there is way more to do to improve those models. They are far from perfect. And that constant improvement, that pursuit of something better, makes it a very interesting field for me.
So you mentioned that you could solve different problems using machine learning, things that you weren't used to. Do you have an example of a problem what kind of
I
problem
do.
did you?
Yeah, I do. So let me give you one specific example. So we were working back then with a company, and that company, it was a system, and one of the system's responsibilities was for guards, security guards, to capture information whenever there was an incident. So think about a security guard at a big store, right?
Mhm.
And there is a fight, and that security guard has to go there and meddle in, get in the middle of the fight, and please go home and call the police, etc. That security guard at the end of the day has to write a report. Okay, so the system we were working on was to capture, one of the goals was to capture those reports. The problem was that those security guards are not supposed to add personal identifiable information in their reports. So they are not supposed to get your ID. They are not supposed to write down your social security. They are not supposed to write down your race or your age or your name. But these are security guards, and it's just too many of them. And even though they go through training, they still make mistakes, and they ask for the person's ID and they write it down in the reports. So this company uh, had an entire department to just sanitize the report. So they had to go through every report and manually make sure that those reports didn't contain the race of the individuals involved in the fight, or the personal names, or anything like that. And that was the way, that was the status quo, that was the way they were doing it. And thanks to machine learning, we found a way to solve that problem just using machine learning. Like we were able to identify personal information as part of the summary and flag it for the people to remove it, to clean that out. So just with that little bit of software, we were able to solve a big problem for that company. They didn't even know that was a problem for them, and we were able to solve it. So that's one of the first examples that I can remember where I make the connection and I say, "Oh, wait a minute, we can actually do this to solve that." And yeah, it was a big light bulb moment.
Okay, so just to put things into context, you're talking when you were working at Levatas, right? And you had some
Yeah, I
flag,
was
yeah.
working at Levatas. Yeah, yeah, yeah.
And what algorithms do you use for this? Is it like NLP, like you understand the language and you have some kind of language
Yeah.
processing algorithm?
So what led me to the idea was reading and researching around NLP. What we ended up using was Watson, which is IBM Watson in that particular case. But is the important thing, like I did not apply an algorithm myself. I took the algorithm and
Mm-hmm.
trained it. I didn't do that. I used a solution that already exists. But it's the connection. What's important is understanding, oh, I can actually solve this problem with these techniques. Now let me go and find how do I actually apply the technique. So we ended up using Watson for that. I mean, we're talking back in the day, we're talking 2015. But yeah, that's what we ended up using. Yeah.
Okay, and it's thanks to the master and thanks to understanding the power of AI and machine learning that you realized that
Correct.
you could use machine learning for this.
Yeah, I
Yeah.
mean, there's so many things around us every single day that we don't see as problems because nobody has shown us a better way of how to do it, right? So you just consider, well, that's part of business. That's what you do in order to solve that problem. Getting exposed to a different field with solutions, with patterns, with ideas, that will definitely, you can definitely take that and say, okay, so how do I apply this here in my life? And you're going to start finding things that you could make
Mm-hmm.
better or solved or whatever. Yeah.
Yeah, no, I see. Yeah, exactly. There are so many problems. I mean, sometimes doesn't not everything needs machine learning. I know also
No,
lots
absolutely.
lots
Yeah.
of people who think, yeah, let's just use machine learning first. We have a problem, we need to use machine learning. Obviously not, but yeah, so many things that you could do with it. So I'm just interested again on based on your background, do you think that software engineer, your experience as a software engineer made you a better machine learning engineer or helped you a lot to transition?
I'm gonna say yes, absolutely. So I have a video. I think I posted a video on my channel talking about that. Most people that I talk to that are software engineers or come from a similar background, they talk about transitioning to machine learning, right? They use the word I want to transition to. And I always tell them, don't think about transitioning. Transitioning implies leaving the old behind and moving on to the new. That's not what you're doing. What you're doing is augmenting your skill sets with machine learning, right? And that's the way I like to think about it. Like at the end of the day, we are building software, and machine learning is just a small piece of a software system. It doesn't matter what software system you have in mind, machine learning is always going to be a very, very small piece that makes the whole system work, right? Now you can specialize. I'm not trying to detract from people that specialized on that particular field. That's totally okay. I'm mostly uh, I'm mostly saying the importance of also getting outside of that small field to try to understand the impact that that
Mhm.
small thing has on the overall solution. So, in my personal experience, people that can speak both languages have an advantage over those that can only see within their area of expertise. Knowing what's outside, knowing how your solution will interact with everything else, it's a huge bonus for me.
So thinking about the problem the other way around, would you recommend data scientist or machine learning engineer to develop their software engineering skills?
So it's really hard for me to generalize because I think every person is different, and every person will, you know, should approach the field first and foremost by doing what they really, really enjoy. Like a person that really enjoys to analyze data, I would recommend to that person, just don't worry with software engineering stuff. Just go at this and be good at it because that's what you enjoy. Like if you hate the other part, I wouldn't want you to do that. Now, on a level playing field, assuming that everyone has the same interest, I would definitely recommend for people to get better at writing software. This is an anecdote. Again, it's just an anecdote, doesn't mean much, but it happened to me. When I was in my machine learning classes, there was this class where we all thought that the hard part of the class was going to be the machine learning theory. It was hard. They made us study a lot to pass that class. But people who failed the class, none of them had problems with the theory. None of them failed because they didn't remember something or they didn't know how something worked. All of them failed because their inability to implement the experiments. And they couldn't implement the experiments because they started the class. It's a very, it's a very tall order to, let's say, take a paper that somebody published and get the same results that that paper did. Imagine you having to do that on top of trying to understand the Python syntax at that point. Like they didn't know Python at that point. It doesn't matter how good you are at theory. If you don't know how to get something done in code, it's going to be really challenging for you. Point being, software skills, writing and the language itself, and knowing how to write good software helped the people who had that during that class. In an industry setting where you're trying to deploy a model, software skills are definitely fundamental, especially if you're working for a small company. If you're working for a big organization where everything is you have these teams, specific teams for specific roles. You have more leeway to be specialized in one area. For the rest of the world, by the way, those are the exceptions.
Mm-hmm.
Like big tech companies are the exception. When you go to any other company, they're going to ask from you a lot. So being specialized is not going to pay off because they need to deploy solutions and they don't have the budget to hire a 100-person team so everyone is specialized in one particular area.
Mm-hmm.
That's not the way they roll. They usually hire multi-purpose teams, small teams, and everyone is going to have to wear many hats. In those situations, knowing software, it's definitely very, very important. So it really depends on what you want to do. If you're going into research, it's very, very difficult. Like you're going to have the time or the attention to try to cover many different areas. You're probably going to be very, very specialized. But if you're going into the industry, planning to work for one of these companies, knowing software it's definitely a must.
Yeah, no, I agree. I work in the majority, like small, well, not small, we are like 300, but yeah, I realized when I arrived there that good code is actually quite important. Like I did a
Yeah.
master, but when you do a master, they're not as focused on the code, and so you just need to make code that works, but the code isn't
Yeah.
amazing. Now, by testing your code, by structuring it, by writing object-oriented and functional programming, you actually realize that your analysis is just better because your code is more structured, you have less bugs, you can produce better
Yep.
work. So having these skills, as you mentioned, it's not needed, not everyone needs it, but if you have it, I think it would improve your analysis quite a lot.
Oh yeah, for sure. Yeah. Yeah. No doubt about it. Yep.
And it's not like we need to be software engineers, like the same level as you, for example, who was a software engineer, but knowing at least the basics is quite important.
Yeah, for sure. I don't think that you need to spend, I don't know, 15 years building software before you're not at all, not even close. But don't ignore that set of skills. So
Mm-hmm.
that set of skills is very important because at the end of the day, again, we're building systems for people to use, and it's software systems where ML is just a small portion of it. So that's the reality.
So I want to move now to talk a bit more about Levatas, the company that you're working for. You're currently the head
Sure.
of computer vision there. First of all, just want to talk about your transition. Like you were first a software engineer, then you transitioned to
Yep.
machine learning. So how does this work? Did you just come back from your master, told them, "Hey, no, I've got a master in machine learning as well. Can I
Yeah.
transition?"
Yeah, no. It wasn't like that. It was more subtle than that. Like we started. So back in the day, we were exclusively working as a consultancy. So basically, companies were hiring our teams for us to solve their problems. And at that point, we started looking a little bit more into clients that wanted AI. So we started looking at AI being a potential way for our team to expand. We started hiring people, hiring a team of specialists in AI, and I was part of the company at that point. When I started my master's, I was the director of software engineering there. So I decided to work with somebody in my company and build that team. Okay, so let's build a team of AI. Let's bring people in and let's start working on those projects. So that was the way the transition happened. Uh, I decided to not be. I'm not gonna do the software engineering part anymore. There are people that can do that. I'm just gonna focus on the machine learning side of things. And over time, we specialized in computer vision. That's the type of people that we hired, and that's what we liked it to do. So that's what we did. Yeah.
Okay, so now the company is focused on building computer vision solutions for clients.
Yeah. Well, not right now, no. So that's how we started. So what we did then is we started narrowing our focus. So right now, what we do is we partner with Boston Dynamics, the Spot robot, which is the yellow four-legged robot that you
Mhm.
see out there dancing videos and whatnot. So we use Spot as the hardware platform to deploy and use computer vision models and a platform that we built. So the goal of the whole thing is for industrial inspection. So we go to a warehouse, for example, and our platform is capable of reading analog gauges and telling you which gauges have a reading that is supposed not to be there. Like maybe the tank is too hot, or I don't know, whatever it is, right? Too much pressure in the tank. We do thermal inspections. We do change detection when something is supposed to be one way but is different way. We do sound anomaly detection. So we have a range of use cases that we solve using computer vision models in the vast majority, and we run them on a robot. That's the product that we built, and that's what we do right now.
All right, so if I understand correctly, robots will use your tool for visual inspection, so to make sure that everything is working as expected on site
Correct.
for a given
Yep.
company.
Yep. Correct.
So,
So think about a warehouse. They have 1,000 gauges inside. This is very normal, by the way. 1,000 is not an exaggeration. It's very normal. A big factory, manufacturing plant with 1,000 gauges, analog gauges inside. The way they have to inspect those gauges right now is sending people. But you imagine just a person having to go and write down the
mhm.
reading on 1,000 gauges. Like it's not even possible. There are even locations within the factory or within this place where people are not supposed to be inside. Like you're not supposed to send people there because it's dangerous. It might be a liability. So the way we solve that is by sending a four-leg robot with a camera and doing that work for us. So we don't have to send somebody; we can send a robot. That's yeah,
Okay. But you're not building the robot. The company is building the robot.
yeah. So Boston is the one that provides the robot. We provide the intelligence of that robot.
Mhm.
So basically, we do the brain. We like to think like we do the brains. They do the body of the thing. Yeah.
Okay, no, that makes sense. And how many, like, because you're the head of computer vision, how many people do you manage, or how many? machine learning
Yeah.
engineers do you have?
So we're a company right now, and the machine learning specialists in our company were under 10. So we're about 10, 11, 9, 10, 11 last count. So we're not too many people. Our company is rather small. We are 30 something people total. So yeah.
Oh, okay, I see. And can you give an example? You mentioned in the early days you were doing like more some kind of consulting, and then you moved to, well, to building a full product for companies. So can you give an example of a problem that you solved using AI?
Yeah. For example, we worked on with an energy company trying to not trying but identifying broken electrical components in the grid. So you can imagine a drone flying outside on the street and taking pictures, and our computer vision models would identify from different electrical components which of them needed replacement because they would look toast or there was whatever bird poop on them. That's very normal. So whatever it was, so our computer vision model would detect that. That's just one example of something that we built. Yeah.
And can I ask why you transitioned from this consulting mindset to building a full product? Is that because you realized that lots of companies had the same problems, and so you just wanted to build
Correct.
something?
So, we found ourselves uh, whenever you focused on a specific vertical, you realize that there is so number one, there is subject matter expertise that costs a lot to acquire. So when you're a consultancy and you're working now with an energy company and tomorrow with a chemical company and the day after tomorrow with a manufacturing company, there is a lot on the way they talk, the problems they have, the solutions they need that's very specific to that industry. So when you're a consultancy, you're constantly having to relearn all of that language, all of that, you have to situate yourself in that world, and that takes time, it takes money to do that. If, however, you focused on one specific vertical, let's say you pick the energy vertical, you're going to work with energy companies. When you go to client number two, you already know all of that language. You already know what their problems are. So the conversation is immediately a match. Like when you're talking to a prospect and you're saying, I know exactly the problems you're facing today. And this is how we already solved those problems for this other company. That connection is really quick. They realize, oh, these guys know what they're talking about. So that's one of the reasons. We also started building tools that we were able to reuse over and over and over again, right? That's why over time, we transitioned to a product company from a consultancy.
All right, yeah, no, that makes sense. So you wanted to be a bit more specific, focusing on a
Yeah.
certain part of the computer vision industry.
Mm-hmm.
I want to talk just a bit more about your managing experience. Like, obviously, managing machine learning engineers might not be that easy. So, how do you make sure that they deliver and that everything works as expected and that they make progress on your technologies?
Yeah, so managing is one of those things that I I doubt anybody can learn how to do it from reading a book. Right, it's something that you have to do. Dealing with people is really complex because everyone has different personality, and it's just hard. It's just something that's hard. Everyone has a different style, and I've been managing people now for a long time, and I think I've developed right my personality and my style around management for many years. My style right now is trust people, and if you cannot trust somebody, that person might not be a good fit to work with me. So I try to trust people and give them as much space as they need to do their best work. So that's just to summarize it in one word. That's what I do. So if you and I are working together, I need to make sure that you have as much information as you need from me to be successful. And I'm going to be relentlessly making sure you have that information. Like, even if you're not asking for it, I'm going to make sure I give you as much information as possible. And I'm going to get the heck away from you so you can do your thing. So I'm trying to be very hands off, very, very hands off. And then we can check, as frequently as you need for me to just sort of like steer you in the right direction. So that's basically the way I would summarize it.
By trusting people, do you mean you're not really telling them you should do A, B, C, D to get there? You're kind of advising
Yeah.
them, giving them some information, and then you let them solve the problem their way.
Yeah. So obviously there are different levels of people. So there are people that are starting their career and they might need a little bit more guidance on what the best way is. So I rarely tell you what to do without trying for you to understand why that's the case. So like, for example, if I tell you, I think you should do it this way, I'm going to try to make sure we have a conversation about what the other ways are. Why would I pick number two instead of number one or number three? My goal here is not to teach you, is not to give you a fish. My goal is to teach you how to fish yourself so you can go and do it tomorrow. For more senior people, uh, I, I I just leave them alone. They usually know more than I do anyway. So I just don't want to get in the middle of it. Again, my goal at that point, my role is a facilitator of information. That's what my role is telling you this is what we want to get, this is what we are. If I know because of experience, because I've done that before, I'm going to tell them where the potholes might be. Hey, just be careful here, be careful there. But they usually know better how to get to that goal. They know how to do it faster. That's it. I'm just going to step back and let them do their best.
So what are common mistakes that junior data scientists or machine learning engineers would make based on your experience? What are the common mistakes that you see and things that people should improve?
Yeah, great question. So first of all, I think is jumping to the code, trying to build the solution really, really quick, without thinking about implications, without thinking about why is this even the solution that we need. I think that's the most common mistake that I see. Like, just to give you one example, I mean, it's not going to be too specific, but anyway, we have to build something for a client to do something. And people usually jump to solutionize. People usually, oh, we could do this and we could implement that and we could do that and just give me 2 days and we're going to have a solution tomorrow. And that's great. That's, it's a great attitude. But by going down that path, you're usually not analyzing what is truly what we need to build here to solve that problem. Do we really need to spend that much time or that much money? I have a couple of I just remember one particular example of one solution that we needed to build. Is just this is not a machine learning specific, but it illustrates the point. So the client needed a map listing the locations of their stores, right? And obviously, the first solution that comes to mind is, why don't we just get Google Map and find a way to send them the addresses of the store and have Google Map display all of the addresses, and we can do this, and they have an API, and people start building that, and in 5 minutes, a designer takes a picture of the map, draws the two locations, and has a JPEG that you can include in your web page immediately. Why do you need a Google Map? Why do you need to connect to an API to display two locations? Is there a requirement for people to find driving directions? No. Is there a requirement for people to zoom in and find what's around the location? No. They want a map with two locations on the map. So even though it sounds like a dumb solution, that solution takes literally 30 minutes to put together versus 3, 4, 5 days. So that's the type of mentality that I like to instill to people, trying to be a little bit more pragmatic, trying to be a little bit more practical, trying to think about how can we get there quicker without over engineering a problem that doesn't need to be that complex.
Yeah, that's a very good point, I think. I kind of think that maybe when you're more junior, you're interested in, the cool stuff like building deep neural networks or advanced transformers, and you're more interested in the model, how you're going to solve the problem rather than
right.
well, the model that you're going to use to solve the problem rather than, getting to the solution as efficiently as possible. I remember I joined my
Yeah,
company and I was like, all right, let's do deep learning. Why aren't we doing deep learning yet? And then you realize that actually, if a linear regression works and solves your problem, you don't need to,
why would you do? Yeah,
have a black box model. So yeah, that's
yeah,
a super good point. I think your example
yeah.
clearly illustrates
That's
this.
it's something that everyone will go through anyway, and I don't think it's inevitable. I mean, I think it's inevitable that people that are eager to learn and show off and do stuff, they're gonna tend to want to use the cool stuff. They're gonna right. They're not necessarily looking into the other side of the business of time or cost. Or those are different parameters that you're not necessarily concerned about. You want to use the best out there, right? So taking a step back and understanding that there are other things that we have to take into account before we build a solution is usually that you have to work with people when they're studying and show them, hey, deep learning is great, but XGBoost solves your problem here. And it takes literally 2 lines of code and you're done. Don't build a neural network for that, right? That's usually, something that you have to show people. Yeah,
Yeah, I would also, always think simpler is just better. If you can build something simple, you will have less bugs, it will take less time.
absolutely.
So always start with the simple thing, and then if the simple thing doesn't work, or if you need something better, then yeah, build a neural network, build something else, but always start with even something, a rule-based algorithm, or something very simple. If that can solve your problem, then you're done, and you spent like a few hours, and that's it.
100%. Yeah.
So the other thing very interesting that you mentioned is you need to think about how you're going to solve the problem. I think people, and even me when I started, you don't really think about the requirements, like basically having a plan or scoping what you want to build and why you want to build this. If you jump straight into the solution without thinking, you're not going to have a clear plan. Um, at some point, you're just going to
Yeah.
try to not going to know why you're doing this. I see so many people trying to optimize a metric and really want to get 1% more improvement. But if you just pause, ask, why do I want this improvement? What's the value? Why do I need to
Yeah.
build this bigger model? Like just thinking and planning is super important as well.
Yeah, for sure. There is also, when you take a moment and think about a problem, usually you're going to be surprised by different ways to tackle that problem that are not necessarily uh, obvious at first, right? Like if you don't dedicate enough time to thinking about the problem, you might not stumble upon these cool solutions. Let me give you one example. We had these, we needed to detect uh, things that are hanging from a board. So if you look here, I have
Mm-hmm.
a board here. So imagine building a computer vision model that detects whether certain instruments are located where they are supposed to be located. So there is a place for a screwdriver, there is a place for headphones, there is a place for, I don't know, maybe a microphone hanging from that wall. And I want a computer vision model that detects whether those elements are in their correct position. When you present the problem, the obvious solution, what everyone is going to immediately try to do is, okay, we just need a model that detects whether a specific object is in a specific place, right? That's awesome. That's also the hardest way to build a model. Now you need to find a model that detects objects and finds whether the object is actually in the position in it, etc., etc. Another possible solution, way simpler to implement, just you print out QR codes, you create a QR code, print it out with a printer, stick it on the wall, and let the object that goes on top of it cover the QR code. And then your model is not detecting objects. Your model is not trying to find a microphone or a screwdriver, is not doing any of that. Your model is only trying to read the QR codes. And if the QR code is not visible, it means the object is there. If you can find the QR code, it means the object is not there and you should signal that there is a missing object. So it's a completely different way to approach a problem that makes the solution we're talking about hundreds and hundreds of hours easier. That solution is only obvious and it's only going to come to you if you dedicate enough time to think about it. I'm not talking about overanalyzing a problem. I'm talking about dedicating enough time to consider, what do we really need to build here? Is it an object detector, or is the problem we're trying to solve, we need to know whether an object is located on the board or not. So just by analyzing the problem a little bit longer, you're going to find creative solutions that are going to make your life way easier.
Yeah, that's a good point. Thinking out of the box is difficult, but can sometimes help solve lots of problems.
Yeah. Yeah, for it, and it, it's, there is a little bit of creativity that goes into this. There is also a little bit of experience of seeing problems being solved for a long time. There is also a little bit of process, and that's what people can affect. Like, you cannot become more creative. I cannot tell you, oh, you just need to be more creative, and you're like, oh, thank you for the advice, I'm going to start being more creative now. That's not a thing, right? Or I cannot tell you, oh, you just need more experience. You're gonna say, okay, great, I know, more experience. You cannot do something with that. You cannot, make time go faster. What you can do, however, is have a process that helps you with these problems, right? Your process should be dedicating enough time to think about this. Your process should be, or should include, how am I going to look at every problem and what are the things that I'm going to analyze for every problem, so I can, you know, get closer to being lucky to find a good solution, right? The lack of process is always going to lead you to just try to do whatever you think is best at that moment. And that's not a good way to approach these problems.
Yeah, 100% agree. Focus on the process. I want to close the computer vision chapter. So you're working at Levatas. You're the head of computer vision. We talked a lot about computer vision. What do you like so much about this field? Why not NLP or something else? Why computer vision?
That I don't have anything against NLP. I just find, extracting knowledge from images, I think it's always been fascinating to me. I don't know why. Uh, it might be, it's not even the first problem that I had to tackle. Like I told you, the first thing that I had to do was with NLP. But just the ability of having something, taking a picture and trying to extract knowledge from the real world based on pictures or videos, there's something magical about that, right? There is something that when you see a model working and doing that, you're like, oh wow, right? It's this. I don't know. Maybe it's because of that, and it one thing leads to another, and I started looking more and more into the field of computer vision, and then you start becoming good at it, and or improving at it. And then at some point you're just too far down the road. I'm like, okay, I guess this is it. I'm gonna keep doing this because I know what I'm doing here. Yeah.
Are you impressed by the latest algorithms like DALI 2, diffusion, all those? Yeah,
They are
text
really
to.
cool for sure. They are really, really, really impressive. I'm actually, as we speak, we're here. I'm recording a video about stable diffusion. So just a quick example of how to use it using TensorFlow and things that you can do with it. So yeah, I've been playing a lot with stable diffusion. Yeah, really,
Cool.
really impressive work.
For your YouTube channel or?
That's for YouTube. I've tried. I haven't found a good way to use stable diffusion in my work yet. But yeah, it's for my YouTube channel. Yeah.
Where do you think that the field is going? Like, what do you think we'll be able to do in 5 to 10 years, given how quickly it progresses already?
Honestly, I cannot. Thinking in exponentials is very hard. Like if I look 10 years ago, right? So just for reference, TensorFlow is from 2015. It's not even 10 years ago. TensorFlow from 2015. PyTorch from 2016. So literally 10 years ago, we did not have any of the two major deep learning libraries that we have today. None of them existed. That was 10 years ago. The field of deep learning 10 years ago was very, very different. It was in the 2009, 2010 where the GPU industry started mass producing these GPUs just for gamers. We're talking about 12 years ago. So forget about deep learning before then. Now, you see where we are today compared to 10 years ago, and it's light years away. And the field should continue seeing an exponential growth. And human beings are not well equipped to think in exponentials. We're not well equipped to think about where are we going to be in 5 years. Somebody said that we usually overestimate what we're going to complete in a year and underestimate what we're going to complete in a decade or something like that. I cannot tell you what we're going to be in 10 years. I just can tell you that we better hold off because I think it's gonna be decent, just like the last couple years has been. It sounds like every single week there's something new. I mean, Stable Diffusion wasn't even hot out of the presses, and we got Meta's text to video generation, which is super impressive as well. And you feel like I don't understand how this thing works. What do you mean you have another big thing out there, right? It's just so fast. Yeah, I can't wait, to be honest with you. It's gonna be very, very different. Yeah.
Yeah, I'm super impressed by the latest things. And as you mentioned, with computer vision and also with language as well, sometimes it looks like it's magic. Like you just type a
Hmm.
sentence, and your algorithm gives you an image of that sentence. I mean,
Yeah.
that's just completely crazy. And now the
Yeah.
results are, well, so
I mean,
beautiful.
it's I've been in the field for long enough to understand that there is no magic in it. But then you see it happening, and you're like, well, maybe I have to rethink the magic thing. But then obviously you get into it and you realize, oh, now that makes sense. It's just a clever way of putting it together. I like Stable Diffusion a lot because they have many different pieces working together. That's what the video is going to be about. But they have many different pieces working together, and it's super cool how they all help each other to get the final result that you're getting. How you can get to a very impressive looking image starting from a patch of noise, because that's where everything starts with just random noise, and they transform that to a very looking image. I mean, seeing all of these small pieces working together is very impressive.
So I want now to move to the last part, not computer vision, but talk about what you're doing outside of work. One thing is you've created binomial or binomial. I don't know how do you pronounce it.
I pronounce it binomial.
Oh, binomial. Okay.
Yeah,
Um,
letter B and then nomial. Yeah.
so do you want to explain what's this website doing and why you
Yeah.
wanted to build this?
Yeah, so binomial is I divide my sort of like my professional life in two, right? So I have my work that I do every day, and then I have this other side of I want to educate people. I feel like there is a huge barrier in front of the machine learning field for people to break through. It's really hard, and that barrier, it's not, I mean, it's not that people are creating that barrier on purpose. It's just sort of like a byproduct of who are the educators, who are teaching machine learning, where is the information coming from, and that usually comes from academia, right? People go to college and you have researchers teaching people, etc. And what that creates is this humongous barrier of technical jargon, of mathematical complexity, and it's not surprising that many people feel very intimidating by it. The fact that in 2022 you have discuss or I have discussions with people that say you cannot be a machine learning person unless you understand how this thing works, right? And all of that is total nonsense, right? It's like telling somebody you cannot drive a car unless you fully understand how the engine of the car works. That's not, that might have been the case 100 years ago. It is not the case anymore, right? We have high level libraries that do a lot of the work for us. That doesn't mean that you should ignore everything that's happening behind the scenes. That means that it's not a hard requirement to fully understand how the things work before you can actually get value out of them, right? So part of my passion is sort of like trying to find a door on that barrier, on that wall to let people through, right? Trying to tell people or teach them, hey, this is actually not that scary, right? There is actually a good explanation for what this model is doing. It's not that complex, right? So as part of that effort, in this case, I do Bnomial. Bnomial is just a website where a friend and I put together daily machine learning questions. We publish them there, and it's fun for people to go and answer that question. So every single day, we publish one question. We've been doing that for longer than 6 months already, without failing one day. So you go there, you answer the question, and we tell you what the right answer is, and we give you an explanation of why that's the answer. So it's a way for people to, based on the messages that I get from people, they use the site to practice for interviews. They use the site to refresh their knowledge. They use the site to learn something new. So some people, they are doing machine learning maybe, but they don't necessarily remember the fundamentals. The website gives them those fundamentals and they can practice. We also have a section that we call time travel, which is very simple. You can answer tomorrow's question. So you don't have to wait until tomorrow. You can answer today tomorrow's question. The difference is that we don't give you the right answer. So if you answer tomorrow's question, you have to wait until tomorrow to see the correct answer. But because you do that, we let you participate in a competition. So everyone who answers tomorrow's question, we have a running leaderboard where, just because there is no way to cheat it, to cheat the leader, like if we do a competition with today's question, you could open a browser, right, get the correct answer, and then answer on the other browser. Tomorrow's question, there is no way to cheat. So we have a running leaderboard. People compete every month to see who can get the highest score every single month, right? So that's our way to, by writing those questions, that's a way for us to study, to learn. I mean, you can imagine how much research we have to put into these questions. People are going to quickly point out every single mistake that we make. And we make mistakes, and people send me angry emails because, hey, this is not supposed to be like this, it's supposed to be like that. And we learn a ton thanks to that, right? So that's our way to contribute a little bit to the community, and also learn. Our own, growth comes through the website.
So two things based on what you said. First is I'm actually also using Binomial and I really like it. I think the cool thing is you have different kind of questions. Like some I would find quite easy and some I would find quite challenging and I will need to do some research online before answering it. And
Yeah,
also, yeah, different types of questions, like not just, which algorithm do you use there, but on everything, loss functions,
yeah.
hyperparameters, I don't know, really everything. So yeah, I think that's really cool because even if you're a beginner, you could try to answer some questions as well. And if you don't know the answer, you can still look online and learn something.
Yeah, yeah. We try to keep questions, the majority of the questions, on the middle side, and I know that's hard to measure, but we try to add a little bit of difficulty to the question, but not as much that only a PhD with a
Hmm.
specialty could answer. So we try not to get there. We also throw in there some easier questions, because it could be surprising for some people, even though they are experts. Some of those very easy questions they already forgot. They already forgot how that works. It's something that they do without thinking, and they do not necessarily know exactly what's happening. So even those easy questions might be challenging for some people. But yeah, we try to keep it very, moving. We try to cover many different areas. So there is everything for everyone. Yeah.
Definitely. Yeah, I think that's a good point of the website. Like you're not, yeah, it's not just too difficult or too easy. So really like
Yeah.
that. The second point, based on what you mentioned, is that you also learn a lot by doing this website and by building it. And I
Oh
realized
yeah.
this by doing a podcast or posting on LinkedIn. You post on Twitter. I'm more on LinkedIn. We can have a debate later on which platform is best. But yeah, I think by, for example, thinking about a question that you need to write, you're going to need to make sure you get the right answers. You're going to probably read a bit about the topic unless you're really, really familiar. So you're going to learn about this topic yourself. And
Yeah.
then obviously you're going to make mistakes. So you're going to learn from those mistakes. So is this some kind of career advice that you recommend if you want to learn, do something, like just build something, just
Oh
do
yeah, for
something?
sure. I mean, 100%. If you want to improve on something, go and do the thing. What I pick to do is just write these questions, but I also write, full length articles and I record my videos. All of that helps me do the thing, right? You can read as many books as you want. Unless you put them in practice, you're not going to be learning. So something that I recommend people is create a habit. I'm a huge fan of having these small habits that will over time will accumulate and make me grow into certain areas. One of my habits is to write one question every single day. That's it. That's my habit. Your habit could be answer that question. It's not only because you go and spend 30 seconds and answer the question and move on. Is well, I'm gonna try to ace this question. So I'm gonna get the question and I'm gonna do some research before I even hit the submit button. That researching is going to take you 5-10 minutes. Those 10 minutes every single day will, I mean, you're going to be a different person a year later, for sure. Just because 10 minutes every single day. That building that habit is so important, in my opinion. That's what I do. Yeah.
Yeah, that's a good point. How do you build that habit? How do you force yourself to do one question every day? Because a lot of people will just say, yeah, I'm going to do that for 2, 3 days, and then, well, it's too much, or well, it's
Yeah.
boring.
I mean, that's it's a great question. I just force myself. So number one, you need to see, I guess, I keep doing it because I see the value coming out of it. So I know that for me to improve, I have to do something. Now, I could be, some people go and do open source. That's great. That's your way to improve. Some people go and build their side application or SaaS, whatever. Uh, I pick this as my daily thing that I'm going to be doing. I like it, like I enjoy it, and I enjoy the learning process. Again, remember, one of my passions is to teach people uh, to get into the field. I feel like Bnomial is doing that for the people who go and answer. We have about, between 13,000 and, 1,300 and 1,500 people answering every day. That's about 10,000 people in a given week, 30,000 people in a given month. So I'm happy with that. So that's a great result. That's a lot of people that depend on it, that do it, show up every single day. And I'm fulfilling my passion at the same time I'm learning myself. So it's a win-win situation for me.
Well, thanks a lot. Yeah, I really like the website. And sorry, I forgot to mention another cool thing is you get a hyperlink with some resources. So in case you get it wrong and you don't know the
Yeah.
answer, you can read about it and hopefully you
Yeah.
will get it right the next time.
Yeah. Yeah, for sure.
So just want to finish the episode with one question. If you had one advice for someone to progress in their career, just one advice, what would it be?
Yeah, do the thing every day. Just it's the same thing that we were talking about, habits, for sure. So I don't know how much time you have, but I'm sure you can. If you want to get into the field, there is no other way than that you're gonna make it. That is not doing it. So doing it might be at the beginning just spending a little bit of time in it. So it might be reading a couple of pages every single day. So if you're motivated and you keep doing it and you can keep increasing that, if you do it, you're definitely going to make it. Always do and try to prioritize doing over reading, over watching videos, over, so always try to prioritize doing it. If you're starting from scratch, you're probably going to have to start with maybe taking a course or a tutorial. The important thing for me is not necessarily the path that you take, it's your consistency. Like if you focused on consistency, there are many, many different ways to get there. Like people overanalyze what is my best course, what is the best tutorial out there. And they keep pursuing this, I need a better tutorial, or I need to keep buying books because my book is not the best book. There is a better book. None of that is going to get you there. Just pick whatever you find and just make sure you're consistent with it. And you're definitely going to see results. That would be my advice.
That's a great advice. I kind of see life as a gradient descent algorithm. You know, you don't need to find the shortest or the fastest path towards the minimum. You just need to pick something in the right direction, right? If you start a book in machine learning, it might not be the best one, but you're going to move in the right direction. And if you take those steps in the right direction, at some point you're gonna, well, you're gonna do
That is
well.
a that is a great analogy for people with experience in what gradient descent is. So I'm definitely still in that analogy, and I promise to give you credit whenever I use it. So it's great analogy for sure.
Cool, cool. Great way to end the episode. Then thanks a lot, Santiago. It was really great to have you on the AI Stories podcast. Have a nice day, and yeah, hope to catch up soon.
Yeah, thanks for having me.
Bye.